Hello, welcome back to my channel. So today I'm going to continue on with my Mathematica tutorials, and I'm on the third one. So last time I did the first, 8 questions I got up to, and now I am on to a more difficult one. Okay, so this one asks to construct a truth table. So I'll just type this out and I'll talk to you about it along the way. Alright, so I am going to construct the truth table for, in brackets, P or Q and not P. Alright, so we've got two letters, P and Q. Alright, so I'll start with creating an array. Z equals the array containing P and Q, the semicolon, because I don't want to see the output, P comma Q. Alright, and then I want to know the length of it, because the number of options is a power of 2, right? So it's one for true, one for false, that's 2 things. Alright, and if I have a P and a Q, each of those have the true, false possibilities, so in total there are 4 possibilities, and that is 2 squared. So I need to know the length, alright, because if I had, say, 3 P, Q, and R as possibilities in my truth table, then I would have 2 to the power of 3 total possibilities of trues and falses, right? So I need to know the length of P, Q, etc. Alright, so M equals the length of Z. Right, and again, I don't want to see the output. Okay, next, let's let N be equal to 2 to the power of M. Alright, I can leave this out because it might be handy to see how many I've got. Alright, and then I want to create another array. I'll call it A. So I'm tabulating, right? So I'll write my brackets in. Maybe I want to see this, so I'll leave the semicolon off. Alright, so what do I want to do? Well, basically, I'll start up here and then I'll copy and paste it inside the table. Alright, but I want to tabulate from, so I'll tabulate over the letter G, going from 0 to N minus 1. I'll explain that in a bit. Alright, so then I'm going to pop something in here inside what I'm going to table over. Now table generates an array, and I can do so over the letter G. So as G varies, I can put, so let's just see. Alright, if I put G here, alright, let's see what we get. Alright, so it's tabulated from 0 to 4, right? 2 to the power of 2 is 4. And you see there we've got 0, 1, 2, 3. So it's generated a list. Now, just to show you, let's just make that 2n minus 1. Should get a lot more, right? Right, up to 7. So that's 8 elements from 0 to 7. And let's just change it, minus 3. Alright, see? It makes a list. If I change this, G to G squared, well, then I'll get the squares of all of these in a list. Alright, so this is quite handy. Alright, but back to constructing a truth table. Alright, so we're going to we want to tabulate over something, but what I'm doing is integer digits. Okay, so I'm going to take integer digits of some number, G, in base 2. Alright, so this should give me the binary representation of G. Alright, just to show you how that'll work, let's just choose one, 11. Alright, now 11 in binary has the digits 1, 0, 1, 1. Alright, so let's just show you what that means. This means 1 times 1 to the power of 0 plus 0 times 1 to the power of 1 plus 1 times Oh no, these should be 2's. Yeah, whoops. 2 to the power of 1, 1 times 2 to the power of 2, and then 1 times 2 to the power of 3. That seems about right. So let's see if this is 11. No, it's 13. What have I done wrong? What? Oh, it's backwards, just like numbers are, of course. Yeah, it's backwards. So just let's just write down a base 10 number, 146. All right. So what is this? All right, it's 6 plus 4 times 10 to the power of 1 plus 1 times 10 to the power of 2, right? Okay, so that should be 146. Yeah, so you write the sum with the digit on the right, so in this case the 6, you put that on the left hand side when you express it as a sum of powers of 10. Alright, so that's what we want to do with 11 as well. So I need to read this 1101 if I'm going this way. So 1101. Alright, so this should be 11. Yep, that's 11. Okay, so I can get rid of this. So in summary, integer digits 11, 2 writes 11 in base 2, but it puts it in an array. Okay, so that's fairly convenient. Now I can get rid of this, semicolon it, semicolon that. So what do I want to do? I want to be able to construct an array of the base 2 representation of an arbitrary number g. Alright, so that's what I want. And now I want all of my numbers to have the same length in this way. Alright, so if I'm looking at the number 3, well, the number 3 is only going to have 2 digits in binary, right? So, but if I want to represent it having length 4, well, I'll pad it with zeros. Okay, so then I want to pad right. Pad right. No, not pari, pad right. This number, and I want to pad it right m digits. M. Okay, so let's have a look at this now. I'll change it back to 11 just so we can see what it does. Okay, so in this case it's chopped it off, right? But that's alright. Now, if I go 15, alright, so there it's put zeros on the right of it, so this is turning this into an array of length 15. Okay, so back to what we want to be general. Put a G, put an M there. Alright, now I want this to be the thing that I'm tabulating over. Alright, so rather than G squared there, I want to have what I've just constructed. Now I can get rid of this. We don't need this anymore. Alright, so let's have a look at what we have. Okay, so what do we got? We've got basically some possibilities for true and false, don't we? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And why 11? Because earlier I said, didn't I put in 11? Let's try that again. Yeah, okay, so I see it. No. This should be 0 and this should be n minus 1 rather than 2n minus 1. Okay, let's have a look now. Okay, that's making sense. So that should be good because we've got 4. Alright, so what we've constructed is a list of true-false possibilities. So, comment to self, list of true f possibilities. Okay, where f is 0 and t is 1, right? So 1 represents true and false represents 0 represents false. Okay, so that's what we've done. We've constructed all the possibilities for that. Now next we want to use these in the truth table for P or Q and not P. Okay, so what do we want to do next? Now we want to construct a new array B, and B is doing just that. Alright, so B equals replace all. This is a very handy built-in function, replace all, and what it's good for is allowing you to substitute a value in without saying it's equal to, right? Because if you put in, say, x equals 5, well then you might forget that you put that in memory, and you've got to clear it from the memory again if you need to use it for something else, right? So replace all is good in cases like that. Okay, so we want to replace all A, and we are replacing 0 with false and 1 with true. Okay, so let's have a look at the output. Right, now this is great. We got false on the left. Okay, so continuing on. Now, next I want to construct a function, alright? A function that I'm building, not a built-in function. Alright, so from that I'll look in my names, book of names, choosing a name for your algorithm. Alright, again, 50-cent book, handy for such things. Right, so I find the name Carol. So I'll go with that, Carol. Carol. It'll be a function of B and J. Okay, colon equals, now I need module. Alright, module. Okay, and I'll put a semicolon after that. Now inside I want to have local variables P and Q. Alright, so then I'm going to say what I want them to take on. So P equals. Alright, now I'm going to show you indexing because I want to pull values out of my array B. Alright, so B, put 2 square brackets, and I'm going to index, I'm going to pull out the jth element of B and the first element of the jth element. Okay, so that's P. So the first one in these down here. So the jth one, I pull out the first element of the jth one and use it as P. Okay, and then I need a Q equals, same thing, J2. Alright, so this is the second element of the jth element of the array B. Alright, so this is the Q value in here, these. Alright, so next, now that we've got that, I want to write out the expression. Okay, so I'm building a function that subs the jth value, the jth possibility into the expression. Alright, so I'll put the expression now, and it was P or Q and not P. Alright, so I want to see that coming out of the function. So don't put a semicolon after this one. Okay, so we've got module, so P and Q are local variables, meaning that we set values inside the function and they're not remembered outside the function. Okay, so that's the function Carol written. Alright, now we want to construct another array. Alright, so L equals, and we want to tabulate, so table, okay, table values of Carol, BJ, and I want to tabulate these. J goes from 1 to 4, right? But 4 is n, so I can put n there. Alright, let's have a look. What did it give us? It gave us false, 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 false. Okay, so it's subbed in values for those possibilities. And now I want to construct a new array, m equals, so I'm tabulating over, say, k. Again, k goes from 1 to n. Alright, and what am I tabulating? I'm tabulating an array this time. B, the kth element of B, followed by the kth element of L. Okay, so let's have a look at the output. So looks like this. Okay, good. So finally we want to see that as a matrix, alright? Because I've constructed an array containing arrays containing arrays. Okay, so this I want to view as a matrix. So I'll just write matrix form. Alright, notice the syntax. Matrix is capitalized and form is capitalized, and it's all shoved together. The two words are one. So this is a typical syntax in Mathematica. If the function has multiple words in it, the beginning of the words are each capitalized. And we have square brackets. Again, matrix form M. Let's have a look, see what we get. Okay, so here we see the values for P and for Q, right? And then when we sub it into the expression P or Q brackets and not P, well, we get a false in this case, false in the second case, false in the third case, false in the fourth case. So what we've got here is we find that this is never true for any of the possibilities, right? So this is what we call a contradiction. Now, if we want to actually put in a top row of this saying what we've got, well, we can do that too, because I can do something to M. See, what do I want to add to the beginning? So to do that, I'll use prepend. Right, prepend, put something in front. So I want to prepend M with PQ, and then okay, I'm going to make it look like the others. And then what was the expression again? So I'm going to write this as a string, okay? So I'll output a string here, so I'll put this symbol, and then it was P. Now I don't have the V shaped, right? Can I use this? Yeah, it looks a bit like OR. Okay, P or Q, and tilde. It was a tilde, right, for not, and that was in brackets, and not P. Okay, so I'm prepending M with that, and I'm going to call this M so that when I show it as a matrix, I'll be showing this with a prepended value in front. Okay, let's have a look. Shift and Enter, so I executed that. And yes, I got what I was hoping for. So here is my computer-generated truth table. Okay, so the next question here is to I'll show you do the same for a more complicated truth table. P or Q implies R if and only if, or you know, the implication going both ways. P implies R and Q implies R. Alright, so let's have a go at that. Now what would we have to modify here? So I go back. Oh, first of all, I should probably show you a good way to save. Alright, so File, Save As. Alright, so you can save this as an NB file. .nb. Alright, and then you can also save as, and you scroll down here and go PDF. Alright, because that's handy if you want to share this with someone, like, you know, if it's an assignment or something and you want to hand it in. Good to save it as PDF, because if you try to submit the .nb file, it can sometimes be just a really large file type. Alright, so if you just need to show it to someone, .pdf, saving as PDF is pretty good. Alright, so save. Alright, it takes a second to construct that, build the PDF file. Alright, what were we doing? We're changing this now to do a more complicated truth table. Alright, so here we've got P, Q, and R. So just include the letter R. Alright, that's going to change the length of everything, so now we're going to have 8 true, false possibilities. What else do I need to change? Probably need to change the expression. Okay, so where did that go? That's in here. Let's try to be clever and maybe even put the expression up front. Alright, so I'll pull this out and call it something. I don't know whether that'll work, but let's give it a go. Alright, so I'm going to call that T equals this semicolon, and I'll put T back in here and see if it still works. Let's have a look. Shift and enter. Well, not really. Not really. Okay, so no good. So you need to put, well, you could do it, right? But it's more work than what we'll do here in this little tutorial. Alright, so clear T, you might use that later. Okay, all good, working. What? That's not what I wanted. So edit, undo. Should put it back so I can copy and paste it again. Where did that go? Can I find it? No, I gotta undo one more. Edit, undo, edit, undo, edit, undo. Probably easier just to type it again. Okay, Control C, and then I can delete that and go and put T back in here. Alright, try it again. Working, yep, that's fine. Well, we've got 3 possibilities here, so that's of length 8. Okay, so now we're going to change this expression. So I'm reading from this. Right, so I need to look up, because I don't remember what this symbol is. So I'll go in the help file, Wolfram documentation, and I'll look up, I'll just type in logic, see what I get. Logic and Boolean algebra. Okay, so let's have a look. So this is the help file for all of the logical symbols, and what I want is equivalent. Alright, so I'll click on that and see if I get some more info on how to use it. Alright, so I'm going to copy this part out. Copy. Okay, close, and I'm going to use that somewhere in here, so I'll just copy it for now, and then I'll borrow from it. So it says this, it's the question, is this logically equivalent to this, right? So that's what we want to use. Okay, so I'll go back to writing this one now. I want a P or Q. That's okay. Whoa, what about implies? I think it's just implies, so let's have another look. Implies. Okay. Yes, so P implies Q. So just put implies P comma Q. Alright. So, yes, I need comma R. And it's read right because the syntax at the moment is not good. So this will give you an error. You want to avoid errors in Mathematica because it's debugging is really a painful process in Mathematica. Now every software has its pros and cons, and I think one of the big cons in Mathematica is debugging if you have a problem. So if you see this sort of thing, just know that you have a problem and you need to fix it. Okay, so I have heard a lot of complaints from people who might be MATLAB users about what it's like to debug something in Mathematica. It's a really painful process, but it has some other excellent features, so that's why I use it, because it's great for symbolic computations, plotting things, and all kinds of stuff, dealing with images. Okay, anyway, that's a digression, so I'll go back to writing implies. Okay, so P or Q implies R. So that's this bit. Okay, and now I'll just put the next one. I'll leave a space. Well, okay, implies P comma R. Alright, for this one. Alright, now this is not good syntax here, it's not going to work. I need equivalent, right? I need equivalent now, so I'm going to copy this. Control C. And put it here, and I need a comma now. So it's the question, are these two logically equivalent? Okay, I'll end that bracket. Right, but I'm not done writing there. I still need and this one. Q implies R. So Control C. And then and. Control V. Right, but I want this to be Q implies R. Alright, so notice that the P and the Q is green in color, but the R is blue in color. That is telling me that R is not being viewed as a local variable in this case, so I need to include comma R in my my array containing the things I want to use as local variables, and then I need to say what it is. Alright, so copy this. I need another one of these, so this will say R equals the third element of the jth element of B. Alright, so now I need to get rid of that equivalent. Alright, yes, I think it's good to go. So let's try shift and enter. Okay, shift and enter, and we have things we expect, true, false, etc., truth values. Alright, and then we scroll down and see what we have, and here is the matrix form of that, and it seems that we have true everywhere down in this column, except this is wrong, right? So let's go and fix that. So where did we prepend? Up here, prepend PQR, and then, well, do I really want to write all that? No, not really. I'll just write expression. Okay, but if you want to, of course you can. Okay, so let's have a look. Yep, I now have my truth table, and of course I could format this a bit better to put this all as elements of an array. Actually, you know what, I'll do that for you. Okay, so how do I do that? Well, I want to get rid of these brackets in here in M, right? And I want each of these to be an element of the array. So to do that, I need to flatten. I need to use the flatten function to get rid of the internal brackets. Okay, so I'll go back here to M. Let's see. I think this should be array flatten. If I want to flatten it within the array, so I'll try it. Array flatten. Now I frequently choose the wrong built-in function here, and then I need to go and look up what it is in the help file. Okay, so that could happen. Let's have a go. Shift enter and see what we get. No, that wasn't helpful. So I'll just flatten it. Okay, flatten. Now it should give me just a list. Yep, that's not what I want, right? But so I've gotten rid of the interior brackets. All right, but I want to now break it up into, so partition is the next function I apply to the outside of this. Partition, I want to partition this into 4s in this case. So that was, I believe, m plus 1. Let's try it. Yeah, so that did the job. Okay. Now array flatten would have done it if I just looked up in the help file how that's meant to work. Alright, but now I have a nice pretty truth table for this expression right here. Okay, so the last thing to notice is that it's all true. Alright, that is called a tautology. Alright, so in other words, these two, P or Q implies R, is logically equivalent to P implies R and Q implies R. Alright, so that'll be all for my tutorial for now. So I'll see you next time.